Okay. And I will share my screen. Okay. Now, can you see the topic schedule?
Yeah.
Okay. So we'll
Yes.
do our homework first. That had exponents, radicals, scientific notation. And if we get a chance, we'll get into probability. Now, remember, Monday is a holiday. We will not be on Monday. I will send you homework that will be due for the Thursday, for those of you who come on Thursday. All right.
Yeah.
Questions on anything? Because that will be a holiday. So you will have homework. I'll send it at the end of the session.
But you sent me two homeworks in the mail.
Yes, but one was college prep, Maureen. The other
Yeah,
one was,
one is for the 11th.
yes, the 11th is when the college prep comes back.
Yeah,
Because remember, they come once a week.
and one is for the 7th.
That's right. That's when the GED comes back.
Yeah.
Well,
Yeah.
you have Monday, but Thursday, it would be the 7th. Okay. All
Yeah.
right. Okay. Did you get yours, Mercedes? I mailed it to you at the same time.
In the mail? No, no, I haven't seen
Yeah, I mailed the same thing that I sent to Maureen. I sent to you.
it. As I came and I checked the mailbox, but no, it wasn't theirs yet. I'll check it later.
Okay. All right. Okay. Let's look at our homework. Let me do a new share.
I did it all wrong.
Okay. Let me do our homework. Mercedes, I didn't get any homework from you. What happened?
I did send homework.
You did? I didn't get it. When did you send it?
I sent it last night. Oh, I don't know if I sent it wrong.
Last night?
I'm
I
looking.
checked my mail today and I didn't have homework from you.
Yeah, I even see it this morning.
Okay. Well,
I
I
was,
checked the mail. I didn't see it. I checked my phone. I didn't see it. Okay. Well, we'll go through it. I got Maureen. Maureen, you didn't want to try the other ones again that I told you you need to try again?
I think I do.
You did?
I do them over there.
Okay. All right. Let's go. Number one. Maureen, number one. Tell me how you did it. What is your answer? Read what it says to do. What does it say?
Didn't we find that we're going to get some water?
Maureen?
Miss Barbara?
Yes.
I'm going to get some water.
Okay. All
I'll
right.
be back in a minute.
Okay. Mercedes, you want to read number one?
it says simplify the following exponential expression.
Okay. Simplify the following as exponential expressions. And you have number one, number two, and 3. Well, actually, they're all there. Okay. And until we get to the radicals. So first part just dealt with exponents.
Yeah, do number one.
Okay. Number one, Mercedes, did you do that one?
No, ma'am.
Why?
I don't know why I couldn't get it done. I tried and just left it and said go back to it in time.
What operation is this? Multiplication, division, subtraction, addition?
Seems like it's multiplication.
It's multiplication. This we can use the asterisk or a dot or X, or we could put it in parentheses, right? So it says 3 times 4 to the third. Now, what does that mean if you expanded this?
You're going to multiply 4 3 times.
Yes, that's right. Multiply 4 3 times, but you multiply that times 3, right? So let me just put that there. And it's numbering, and I don't want it to do that. Okay. All right, let's put this here. Now this translates to 3. And let's just put our asterisk. And this translate, like you said, 4 by itself 3 times. So it's 4 times 4 times 4. All right. You with me?
Yes, yeah.
Okay. Now, Once you have this, let's just copy that over again and you tell me what that's equal to. So this then is 3. What's 4 times 4 times 4 times 4? Mercedes.
That's 64.
Yes, 4 times 4 is 16. 4 times 16 is 64. That's correct. So let's put our 64 here. 6, 4. Take out these 4s. Now, Mercedes, what is 3 times 64?
Um, well, that's 192.
192. So what is the answer?
Oh Lord D.
Answer D.
Maybe that's why I'm paused. I look at the 4 to the third power, but I don't show what to do next. That's why I just leave it.
No, but you said 4 to the third is 4 times itself 3
Yeah,
times.
that's what I'm saying. I agreed to right there, but then I says I'm not sure what to do next. I
Did
leave
you
it.
put the 64 there?
No, I just stop. I just leave it.
But you know 4 times 4 times 4. You just told me.
Yeah, but sure I don't know what to do with the 3 now. I said I'm not sure. I leave it. I should have tried.
Well, it's a multiplication, right?
Yes.
It's still a multiplication. It's a multiplication here. It's a multiplication here. It's a multiplication here, right? So you expanded, you expanded that 4 times 4 to the third to 4 times 4 times 4. You told me 64. It's still a multiplication. Now it's 3 times 64, and that's 192, and answer D.
I should just multiply the 64 by 3 then.
That's right. That's right. Because that's what it says. 3 times whatever 4 raised to the third power gives you. And you told me that's 64.
Too doubtful something.
I'm back with Barbara.
Okay, Maureen, you had this one correct.
Yeah.
Okay. And I just explained to Mercedes how to do it because she said she was puzzled. But yet she knew 4 to the third is 4 by itself 3 times. 4 times 4 times 4. Then you take the 64, multiply it by 3. She told me 192. That's choice D. Any questions, Mercedes?
Mama, I don't think I'm in an error with this part.
What is it?
I wasn't sure what if I would be right with it to get in try.
Yeah, but you should have stopped here. You told me it's 4 by itself 3 times, and you know what that value is. So you didn't get here where you said 3 times 64?
That's what I'm telling you, and I stopped there because I'm doubtful and sure what to do next. So I stopped.
You stopped where?
At
Right here?
At 64, yeah.
Okay. You stopped here where you had 3 times 64?
Yes, yes.
Oh, but you knew this was a multiplication, right?
The sign I tried to just for the 4 to the third power multiplication alone. I wasn't sure whether to subtract or
You
what.
wasn't sure what was subtract.
3. If I should subtract 3 or what?
No, Mercedes. Why are you changing operations? It's a multiplication.
So,
it's not going to change in the middle of the problem.
Okay, so what I want to know, when I see it like this another time, I mean it goes for the both sides to multiply.
Well, it's one sign here, right?
Yeah.
This is saying 3 multiplied by 4 to the third power. That operation is not going to change. It's still multiplication. You follow me?
Yes, ma'am.
So you make the 4 to the third. You clearly said 4 times itself 3 times, and that's what that is. You got 64. It's still multiplication. No change in the addition, subtraction, division. Is still multiplication, except now it's 3 times what you got when you took 4 and raised it to the third power.
Okay.
You got it?
Yes, thank you.
I think sometimes I'll say these, you make things a little more complicated than they are. And then when you look at it, you say, oh, is that it or is that all, right? You ask yourself that.
Too doubtful, that's what.
Yeah, you got to remove that doubt. You got to be confident that these problems are pretty straightforward. I mean, we have some that goes into more than one operation, but that would be in the problem. Like it could be a multiplication and an addition or whatever, but here it's just one operation right there,
Yeah,
times. Okay.
yeah.
All right. Let's go to number 2. Now, number 2, Maureen, did you have this one right?
You got that wrong.
What did you get?
I gotta do that. There we go. I'm gonna get in.
Yeah, I think what threw people here, let me ask Mercedes. Mercedes, what answer would you put for number 2?
Choose, I choose B.
You choose B.
Yeah.
Okay. Now, there's something that's missing here. Now, this 2, what do you call this 2 in math terms? Mercedes, what do you call that 2?
Is that the
Go ahead, say it.
coefficient?
Coefficient. Very good. So you have a coefficient, you have a base, you have a power. So when you multiply with the coefficient, you have to do what? You have to multiply the coefficients and add the powers. Right? So what would be your answer on this one, Mercedes?
Oh,
Multiply
A.
the coefficients, add the powers. What did you say?
A.
That's right. Answer A.
I did choose A first, and I'm remembering. I said, I try to remember what you said, that we should only do the variables alone. So I said, okay, then I shouldn't touch 2. So I changed from A to B when I could get it right.
No, I'm trying to point out to you that you have 3 parts. See, if this was x to the third times x to the second, you just add the powers, 3, 2, then that would be x to the 5th, right? But when you put coefficients in there, you have 2 operations. Multiply the coefficients, add the powers. Got it?
Yes.
So this really, let me just put this here and just expand that for you. Make it really, really, really clear. Okay, let me go here, put this here. Okay, so this expands to, it's not number 3. Okay, this is equal, let me just say equal. So let's see, we factor out the 2, right?
Yes.
So that's 2. Let me just, that is 2 times x to the third. Okay, so that's really 2. I'm putting the x here for, no, I don't want to put an x. No, let me put the, okay, so that's 2 times 2. And all of that is times x to the third times x to the second. So let me just put that x to the third in the parentheses. Okay, so that's x to the third. Okay. And let me put my x to the second. Just copy the x to the second. But you got to deal with those coefficients, right? So let me put the exponent. Okay. And close those parentheses. Now, you have 2 times 2 is what, Mercedes?
4.
And what do you do when you're multiplying powers? What's the rule?
You add.
That's right, you add. So this is 4x. And let me just put here, that would be 3 plus right? That's
Okay.
how you get 4x to the fifth.
Yeah, I understand that part, but I don't know what come in mind and says, which of them is Barbara say don't touch the coefficient, just add the power. So I said, okay, it's B then, because I'm looking at A all the time.
No, but see, if you had just the base and the powers, you add the powers. But if you have coefficients, you've got to multiply those coefficients. See, 2 times 2 is 4, and then add the powers on your base. Your bases
I'm
are all
up to
x.
with another word, with another maths miss.
I'm sorry.
I think I mix it up with another maths proverb. Another
Oh,
maths.
yeah, I think probably,
One of them that I shouldn't touch the coefficient. Just do the power. One of them I mix up that.
yeah, I think so. Okay. And actually, we're going to look at some of these because I think we probably need a little more practice when you have the coefficient. Do some with coefficients, some without. So that's number 2. Maureen, you understand now?
Yeah, Miss Barbara.
Okay. All right. Let's go to number 3. Now that's a division. Now this one, you don't have a coefficient, right, Mercedes?
Which one? Number 3?
Number 3.
No.
That's a division. So same base. So it means you subtract the exponent of your denominator from the exponent of your numerator. So that becomes what? 6 to the what, Mercedes?
6 to the what? Positive or negative 2 power.
6 to the second power. That's right. So you get 6. Let's just put it here. 6 to the second power. 5 minus 3 is 2, right? Now, do you see that answer there, Maureen?
Oh,
You don't see that answer?
yeah.
What's the answer?
B.
That's a minus 2, Maureen. How you making a 2 a minus 2?
Oh. Oh.
6 to the minus 2 is not the same as 6 to the second power. 6 to the minus 2 is 1 over 6 to the second power. So what's the answer, Mercedes?
Wait a minute, miss. I see I choose B because I see 6 to
Oh, well, the answer would be D.
That's right. No, Mercedes, you saying the same thing Maureen said at first. 6 to the minus 2 is not the same as 6 to the second power. 6 to the second, remember when you told me you said that problem before we had 4 times 4 times 4? So this is 6 times 6. And what's 6 times 6, Mercedes?
30.
36. So your answer is what?
So wait a minute, miss.
You know that the first answer I have, I changed it. You know.
Okay, Mercedes, what's your
I
question?
thought it was the subtract.
I am mixed up with this one, miss. I don't get something clear here because I look at it and I says if you extract, take away 3 from 5, you leave 2.
That's right, 6 to the second.
So I said 6 to the. I chose B for the answer.
But that's what I'm telling you, Mercedes. 6 to the minus 2 is not the same as 6 to the second. 6 to the minus 2, let me just copy this. Okay, 6 to the minus 2, let me just put it over here. 6 to the minus 2 is equal to 1 over 6 to the second. Remember the negative exponents? 1 over the reciprocal? Not the same, right? So this is 1. Let me put on the line here. 1 over 6 to the second. So that's not the same as 6 to the second, though, right? 1 is 36. 1 is 1 over 36. Got it?
So you're saying that when I got 6 to the second power, I should have just multiplied 6 by 36.
That's the only answer it matches.
Here we go again.
Maureen did the same thing, right, Maureen?
Yeah.
She just made her minus a plus,
Oh,
right? You see why these are not the same, Mercedes?
yeah, I see it right now.
6 to the minus 2 is 1 over 6 to the second. That's 1 over 36. That's not the same as 36.
Okay.
You got it?
That was the first answer I had, but anyway, I'm not quite sure.
You
That's
wasn't
right,
sure of
different-
this one?
Number 3 had that, but then I cancel it and wait a different one because I didn't sure.
But just remember that when you put a negative on your power, it's not the same as when it's a positive. You see, 6 to the minus 2 is 1 over 6 to the second. 6 times 6 is 36. That's 1 over 36. This is 36 over 1. Not the same.
Oh,
Okay.
You had 36 balls. that's not the same as having 1 over 36 balls, a fraction of a ball, right?
Okay. Okay. Oh boy. This one.
Questions on number 3?
no.
This was
So-
a test if you really understood the negative power.
I was certain I got it right.
And Maureen was too.
Yeah.
Oh boy.
But you can't make a 6 to the second or 6 to the minus 2. They're not equal. You understand? They're not equal. So the only answer that's 6 to the second is the number that gives you when you multiply 6 by itself. And that's 36. You got it?
Yeah.
So don't make that mistake now, because you knew this was a minus 2, Maureen, yet you said it was the answer.
Yeah.
Because when you did your division, you subtracted the 3 from the 5 and you got 6 to the positive 2. Yet you picked to the negative 2, not equal. Got it?
Yeah.
Okay. Mercedes, you okay?
Yes, I'm okay. Just disappointed that
Yeah, you got to read these and not try to make them something they're not. Just remember the negative exponent of something is not the same as the positive. Those values are not the same. Hello, Chastity. See Chastity song.
So when it says like that is a division.
Yes, this is division. And you
Okay.
said 6 to the second.
Okay.
You said 5 minus 3, and we got
Oh.
6 to the second right here. But
Oh.
6 to the second is not the same as 6 to the
Okay.
minus 2. Got
Okay.
it? Mercedes, you okay?
yes, yes. I'm
I gotta
fine.
remember that. Yeah.
Just remember that.
Okay.
Okay. Mercedes, number 4. What's the answer?
Oh, what was the answer I have for number 4? I have A for number 4.
That's correct. Anything to the 0 power is a 1.
That's a good one, right?
Maureen, you had that correct, right? Yeah, you had
Yeah.
that correct.
Yeah.
Okay. Any number of variable to the 0 power is 1. So 8
Uh-huh.
to the 0 power is equal to 1. Answer A. Now here is one, Maureen. You did not give me the right answer. You know what it is now?
Yeah.
What is it?
Yeah.
That's right. Okay, answer A. Mercedes, you know why it's A?
Which one you talking about, miss?
Number 5.
Oh, I didn't go to number 5. Hold on. Oh, I have A too. A is my
Okay.
answer
Oh, okay, so why did you get A, Mercedes?
because
Just copy that.
the coefficient is of the minus. The bigger number carries the sign, so you have to carry forward with the answer.
Okay. All right. Because the minus 9x to the 0 is a 1, right?
Yeah.
So this translates to, let me just put that. Okay. So that, you're right, we still carry our negative. And this is a 1, right? Not, remember I said any number, variable combination to the 0 power is 1. So this would be translated to 1, right? And that's the same. We take parentheses away, it's same as -1. Very good. I'm glad you got that one correct.
I must have a pat on the shoulder.
Mhm. I think, Maureen, you first said 1, right?
Yeah.
Okay, but you can't throw away that negative sign.
I didn't have 1, I had 9.
Yeah, I know. You had, well, you didn't
Got
have
it
the negative
wrong.
here. You didn't,
It's only saying that you said, but may do it over, I realized what it was.
but you had the negative here. That negative doesn't change. It stays negative. Whatever is in this parenthesis, whatever that translates to, it's a negative. So the 9x to the 0 translates to a 1 because
I got to check my phone. I can't remember if it's negative. I don't report negative, so
you understand now why it's a negative?
yeah.
Okay.
But like how you got the negative and then the parentheses, I didn't see
Right.
that negative. And if it was a just a plain 9.
Oh, you didn't see the negative right here?
So I gotta check back my phone and see if I make a mistake.
Oh, okay. Because it made it pretty big. The negative. All right. Questions number 5.
Thank you, miss.
All right. Mercedes, simplify the following radical.
My answer is A.
Your answer is A. What's yours, Maureen? I think you had it right, didn't you? Maureen, did you have it right?
You said I had B and you said it was right.
Yeah, B is right.
Yeah.
Now, Mercedes, you said A. Maureen, I want you to tell Mercedes how you got your answer. Let me copy it. Tell me, how did you get your answer?
Wait, miss, let me give her why I choose A.
Okay. All right. Tell me why you chose A, Mercedes.
He said simplified 2 2s is 4, miss, and 4 times 6 is 24. We did that before like that. So that's why I choose A. Because it's like a perfect they call it again. Square.
Okay. So what are your factors of square root of 24?
I would say
Okay, let me just put this here and you tell me what your factors are. Just put square root of 24. Tell me the factors that you had for the square root of 24. Well, the factors of 24 are what, Mercedes? Just give me factors of the number 24.
2, 6, 4, 12, and 24.
Okay, so,
And
all right.
1.
All right, so tell me the factors in square roots that this translates to.
In square root.
What are the 2 square roots? What are the 2 radicals I can put for the factors of the square root of 24? You gave me the factors and you gave me 2 that are correct. Tell me what to put here for the factors of the square root of 24, radicals.
6 and 4.
6 and 4. So I put, this is a 4. Reason I put the 4 first because it has the perfect square root, right? And then 6. All right, so let's just put that. Now we've got our factors in radical format, right? So let me just put this all on the next so we can just, all right, here we go. Now we had 2 times square root of 24. Square root of 24 factors into square root of 4 and square root of 6. So this 2 times square root of 24 becomes 2 times square root of 4 times square root of 6, right? So this is equal to, we had a 2 already there, a 2. And we have our factors of our square root of 24. Let's just put that there. And that goes behind the 2. Now, Mercedes, what does that translate to?
How do I translate this one?
What does, on the right, 2 times square root of 4 times square root of 6, what does that translate to?
Okay,
What-
2,
What's the
two,
square root of 4?
2.
Okay, so let's just put a 2 here. I'll put that in parentheses because we already have a 2. Take that out. Now you got your answer. What's 2 times 2?
4.
4.
And 4, 6 is 24.
Okay. So let me copy that over and you multiply that out. That's a 4. So let's 2 times 2 is 4. And what answer is that, Mercedes? A, B, C, or D?
That answer show B miss, but I don't. I'm confused right there because I do the square root same way, and we double up this the 2, so 2 2 is 4, and 4 6 is 24. That's why I was sure that answer the answer. Because when I look at B, I would say 4 4 is 16. If I say 16 times 6 cannot be 24. I'm kind of confused right there.
Did you translate did you take your square root of 24, your radical, and factor it into 2 radicals? Like we did right here. Did you do this?
No, miss, because we did some last week. And I see something I actually like this, and I just added. I said 2 2 is 4. 4 times 6 is 24. So that's what, because we did something similar to this.
But you must factor your radical. That's your first step. Take this radical, factor it into 2 radicals where one has a perfect square root. That's why we use only 4 and 6, because 4 is has a perfect square root. But this first step is what you should have done right here. Square root of 24 is square root of 4 times the square root of 6.
So you're saying right there that I know that 4 can go into 24. Definitely.
Right? And with 6.
And you
right?
get 6.
Yes. So then you can take that same 4 and 6 and put it as radicals. If 24 factors into 4 and 6, square root of 24 factors into square root of 4 and square root of 6. You follow?
I'm following you, but I just can't comprehend it. Why A wouldn't work.
Mercedes,
How did you get A, Mercedes? How did you get A?
I look at the 2 and I says 2 2 is 4, and 4 6 is 24. But then you're showing me that I should have break up the 24 into 2 radicals.
If you
So
said 2 and 2 are 4, then Mercedes, why did you pick 8? Because you just told me you said 2 and 2 are 4. Why did you
no,
put the 4 here?
you wouldn't see the 4. You know in your head that 2 2 is 4 and 4 6 is 24.
Okay.
So I thought that is another way to show that 4 is a perfect because I'm looking at now, I'm saying A and B could be an answer, but you're saying that
No, how could A be an answer?
maybe I misunderstood something there. So I understand what
Okay,
you,
Mercedes, let me ask you, how could A be an answer? If I say 2 and I got a 2, right? Square root of 24 does not translate to square root of 6. So how could that be an answer? If you pick A, you're saying you kept the 2, right?
Yeah.
Kept the 2. You're saying square root of 24 can be factored into just the square root of 6. But that's not correct, right?
You're saying that if I choose A, it means,
It means, okay, you said, let me just take square root of 24, put what you just said to show you that that cannot be your answer. Okay, let me just put that here. Okay. Now you are saying your answer was A, right?
Yeah.
So let me just put what you said your answer was. You're saying that's equal to, let me just put, you said 2 times the square root of 6. Let me put the 6 there. All right. But 2 times the square root of 24, it has to be 2 times 2 radicals that multiply to give you 24. Square root of 6 does not give you square root of 24, right?
okay, see if I understand what you're saying, man. As I speak, you're saying it is saying to me 2 times the square root, that's what it means, of 24, right?
Yes,
If I say 2 times the square root of 6, it cannot be that answer.
right.
Because
Because when you
because it,
simplify, these two are not equal.
because if it's, let me see if I get what you're saying. You're saying if I say, if it says to me 2 times the square root of 6, it means 36. That's what it's saying to me.
No, square root of 6 is said a number, and this would be by itself because it's not a perfect square root. You'd have to look it up do it on the calculator, and it wouldn't be. It would be what, 2 point something? Because 3 times 3 is 9, so it'd be 2 point something. In other words, when you simplify 2 times square root of 24, you cannot get 2 times square root of 6. Because you're saying square root of 24 factors or just square root of 6. We know that's not true. You follow?
Trying to get it clear in my head.
In other words, Mercedes, excuse me, I had to drink some water. In other words, square root of 24 has to translate into 2 radicals that when multiplied give you back the square root of 24. Square root of 6 is not multiplied by anything here. So it cannot give you square root of 24.
Oh, so 2 times 12 is 24. That's what you say that's how I should think. Because I cannot say 2 times 6 is not 24.
That's right. Well, remember, your factors don't change because they are radicals, Mercedes. In other words, if you say 6 times 4 equal 24, right?
Yeah.
Well, if you put them as radicals, it is just radical square root of 24. Let's just put that here. Okay. So without the radical, I put them in, right? So let me put, so this will be square root of 6 times square root of 4 equal square root of 24. It's just that now they have a radical that they're under. So when you told me square root of 6, you're leaving out one of your factors, right? Because you're saying square root of 24 is equal to just the factor square root of 6. We know that's not true. Correct? Are you following me, Mercedes?
I'm trying to follow you.
In other words, because it's under the radical, the factors are the same. 6 times 4 is 24. Radical 6 times radical 4 is radical 24.
So you say the answer, what? B, you say B?
Answer was B because square root of 24 factors into these two radicals right here. Put them right here. Square root of 4 times square root of 6. And
So
I put this, go ahead.
because you're saying because 4 go into 24 6 times and 6 go into 24 4 times. That's a perfect square.
That's right. The 4 as a perfect square root. 2 square is 4. So you try to pick radical factors where one of them has a perfect square root. At least one of them has a perfect square root.
Okay, okay. So if
So-
because I use A, if I say 2 into 24, I'm going to get 12. While could you scroll down a little bit, miss? Yeah, while I want to see the answer sheet. Okay. So if I say 2 into 24 would be 12. 6 into 24 would be 4. So that make it not a perfect square then. Because if I divide 24 by 2, I'm getting 12.
Yeah, but then you can't multiply 4 by 12. You get,
okay,
we get more
Mercedes.
than 24.
Okay, Mercedes, you saying 2 times 12 equals 24. That's correct. But neither one of those has a perfect square root.
Because if I say, okay, let me finish this part then. Why is that a perfect square root? Because if I say 2 is 4, and if I say 12 is not 24. Am I correct now?
Say what you said again.
Why these two numbers, 2 times 12 is not a perfect square, right?
No,
Because
no. You take them separate. You look at both numbers. 2 is not a perfect square root. 12 is not a perfect square root. So they don't make good factors when you're trying to put them as radicals.
yeah, because you have to do like 2 is 4, right? And 12 is 144, right? That's why they're not a perfect square.
No.
For 24.
In other words, Mercedes, if you take square root of 2 or square root of 12, neither one of them give you a perfect square root.
Yeah, and I'm sort of getting the understand by agreeing by saying because 12 is for 144.
No, we're not talking squares right now. We're talking square roots. In other words, we're talking square root. Okay, let me just put
No,
this.
Miss Barbara, I understand. You just want to prove a point to see if to prove to you that I understand what you're saying now. You say it cannot be a perfect square root of two numbers to 24 because if you multiply each by themselves, you're not going to get 24. That's what you're saying to me. That's why
That's what I'm saying to you.
yes.
Square root of 2 and square root of 12 are not good factors for your
Okay.
radical because square root of 2 does not translate to a perfect square. There's no number you can multiply by itself and get 2. There's no number you can multiply by itself and get 12. Follow? I'm not talking about 12 times 12.
Okay.
That would be square root of 144.
Yeah.
Okay, I'm saying that if you plug these into your calculator, you'll get a decimal.
Oh,
Also here, you'll get a decimal. 3 times 3 is 9, 4 times 4 is 16. It will be between 3 and 4, 3 point something. This one would be 1 point something. You follow?
oh.
You follow why you wouldn't use 2 and
So,
12?
okay, okay. So tell me the difference now with the answer. Like we just clear out 2 times 12.
When you
What's the
say the difference, and I'll say these, I don't understand what you're saying.
Okay, you'll explain to me why 2 times 12 cannot be a perfect square root.
Well, 2 is not a perfect square root, and 12 is not a perfect square root. So
That's why.
neither one of them are good factors for the square root of 24.
So what makes 6 and 4 a perfect square root? Is
Well,
it
it said one
divided
or
by
the other has a perfect square root. 6 is not a perfect square root. That's why it's still part of your answer. Square root
Okay,
of 4 is 2. They don't have to both be perfect. You need at least one of them as perfect.
okay, okay.
You got it? And the perfect one is the 4, because square root of 4 is 2 squared. 2 times itself is 4. Is it making sense? I'll say these.
Yes, it's Barbara.
Okay, let me just take one here. Suppose you had, let me just take here, just to make sure you understand this. Let me put here, okay, well, I'm on the next. All right, okay, let me make this 48. Okay, Mercedes. Now I give you square root of 48. Now, all I want you to do is to simplify this into 2 square roots where one of them has a perfect square root. What 2 numbers would you tell me?
24.
Not a perfect square root.
Okay. Is it 2 and 12?
Neither one, we just went through those. Neither one a perfect square root. And they're going to give you 48. 2 times 12 is 24. Remember, they have to multiply to give you
So it's 2 and 24 then?
neither one a perfect square root. So what are factors of 48 and 1 is a perfect square root? I'll say these.
Okay, the factors of then the 48. 1, 24.
Not a 1, because 1 times 1 is 1. Think of the numbers that have perfect square roots. What are some of the numbers that have perfect square roots? I'll say these. Just give me like 3 of them.
6.
No, not a perfect square root. Remember, it has to multiply by itself to give you the number.
Yeah, but you talk about any number. 6 is 36. Isn't that a perfect square root for 36? Or am I mixing it up?
No, 36 has a perfect square root of 6.
Oh,
Think of the numbers that have, Maureen, give me
all right,
3 numbers that have perfect square roots. Maureen,
what about 8 and 6 for 48?
no. Maureen, give me
Uh,
3 numbers that have perfect square roots.
4, 9,
Yeah, 4 has what? Square root of what? Square root of 4 is what, Maureen?
2
Square root of 9.
is 3.
You follow, Mercedes? She gave me 2 numbers. They both have a perfect square roots. Square root of 4 is 2. Square root of 9 is 3. Give me 2 more, Maureen.
Okay, the square root of 16 too.
Okay, so 16 times what number gives you 48, Mercedes?
4.
4 times 16 is 64.
Uh-oh.
16 times what number gives 48?
Okay.
48 divided by 16. Not the math.
What did you say?
48 divided by 16.
You get 2?
2 times 16 is 32.
Okay. So the answer is 3.
3. That's right. Okay. So this is 16 a perfect square root, Maureen? She just told me.
Yes,
It is. Now, Mercedes, what number multiplied by itself to give you 16?
4.
4. It's a perfect square root, right? So if that's a perfect square root, I can put here, right? I can break this into square root of 16 times square root of 3, right? 16 has a perfect square root. And this would be a 3. Say, Lisa, you following me?
So I'm mixing up then. That's why. So right there, 3 times 16 give 48.
And square root of 16 times square root of 3 is square root of 48, right? Now, Mercedes, what's the square root of 16?
Um,
you said it just
4,
now.
4, 4,
Well,
4.
wait, Maureen, I'm talking to
4.
Mercedes. It's 4, right? The number by itself to give you 16. 4 square give you 16. So this is a 4. And that would be square root of 3. So that translates into 4 times the square root of 3, because square root of 3 is a prime number, does not have a perfect square root. Mercedes, you following me?
So you're saying right there, square root of 16 is 4 and 3?
The square root of, well, let's start here. We're simplifying the
Okay.
square root of 48 into 2 radicals. One has a perfect square root. That's the 16. Square root of 16 is a 4. So this will be 4 times square root of 3. Square root of 3 is as simplified as it can get.
So you're saying 4 is the square root of 16 times 3 give you 48?
No, don't mix things up. I said 48 factors of 16 and 3. Radical 48 factors are square root of 16, square root of 3. Square root of 16 is a 4. So this is 4 times square root of 3. The 4 is really a coefficient of the square root of 3.
Okay.
Got it?
Okay, Clever, yes.
Okay. Is it making sense? Mercedes?
Yes, a lot.
Yeah. I gave you a list of the perfect squares and the square roots. You have that list, right?
I should. I want to check it out. Then.
Yeah, I gave it. I emailed that to you some time ago. Because that will help you in picking out your radical factors.
Okay.
Okay. You see how once you know those, it really helps. You see how Maureen gave me some that are perfect?
Yes.
Some you just really know. Like the 4, the 9, the 16, 36. Square root of 36 is what, Mercedes?
Square root of 36 is 6.
That's right. So you know them too. Just have to use them.
Okay. Yeah, I'm getting it now.
You got it? All right. Still simplifying. Square root of 243. Mercedes, give me 2 factors that you multiply and get 243.
What did I do? Okay. What number? That's number 6.
Number 6, right? Now, you can just start with the 243 by itself, and then you
But
can
that's
get to
7.
the
That's number 7.
Was it 7?
Yeah, I'm saying, look, I'm looking.
Oh yeah, this is 7. That was
Yeah,
6.
7. Yeah.
Thank you, Maureen. This is number 7. Okay.
So my answer for 7 was, it is C. It can be wrong too, but
Okay, that was let me put this back here. Okay. So your answer was C, and that was correct. Now, Mercedes, how did you do 7?
okay, what I said was, I says 9. 9 times 9 equal to 81. And I say 81 times 3 would give me 243.
Okay.
That's what it-
Now,
that's- you see that, miss? You see that? That's how I checked the one before this one. I was certain the number A was correct. Because I said 2 is 4 and 4, 6 is 24. So I come back and look at C and it says, oh, 9 is 81. And if I multiply 81 by 3, I get 243.
okay, because the factors of 243 are 81 and 3, and 81 has a perfect square root, right?
Okay.
You had to take 81 having a perfect square root of 9, correct?
The 9, oh yeah, 9. That's
Okay.
why I thought number 6, 2 was a perfect square root because I said 2 is 4. But I sort of understand what you're trying to tell. The numbers are different.
Okay. Yep. Not the same. Okay. So this factors into, you take these numbers out. No need those. That factors into square root of 81, square root of 3. Square root of 81 is a 9. There's your 9. So it'll be 9 times square root of 3. Now, Mercedes, I'm trying to figure out how you did this one and you didn't do the other one. Was it because it had an extra number?
What? Which?
The one here that you got incorrect. 2 times the square root of 24.
It's, let me see. No, I choose A for the answer.
No, you for this one you said
For number
yes. Yeah.
I, yeah,
The reason you chose A because of what?
because I says 2 is 4, and 4 times 6 is 24. So I see where I get a perfect square. So maybe I'm wrong when you explain it. That's the reason why I choose it. Then I go back and do the same thing with 7. And I get
But
back,
you said 2 2s are 4.
yes. And 4 times 6 is 24. That's why it says, oh, it's
So I don't understand how you put a 2 when you just told me 2 2s are 4. That would be your 4,
no,
right? You
no,
follow?
look at, oh, you're saying because 4 is already at B. So then
No, this one has a 2. And when
yes.
you take the square root of 4, that's another 2. And 2 times 2 is 4. So you're saying it, but you're not applying it. You said 2 2s are 4, and then square root of 6, but yet you picked A. I was trying to figure out how you got 7 correct and you missed 6. That's because you didn't multiply your 2 2s.
You see B, when I look at B, I say 4, 4, 16. And if you multiply 6 by, if you multiply 16 by 6, you cannot get 24. That's why I said
No,
no.
it's not 4 4s. This 4 came from this 2 and the 2 from the factor of 4, which I mean, when you took the square root of 4. That's how you got that 4 coefficient, right? You took the square root of 4, a 2, times the 2, and that's how you got the 4.
Yeah, but I look at it a different way. Why I didn't choose B?
Why didn't you choose B?
I look at it a different way why I did not choose B.
Yeah, tell me why didn't you choose B?
Okay, because if I say, I look at B, at first I said 4, 4 is 16. And if I'm going to take 16 and multiply.
Wait a minute. Why did you say 4 is 16?
That,
Why did you say 4 is 16?
because I think that's the right way to do it.
No, this is simplified form. So you ask yourself, how do you get the 4? How do you get the 4? From the 2 that's already there, times the 2 that's the square root of 4.
Oh, no, I got what you're trying to
You
say.
see what I'm saying?
Yeah, I just got it.
You
Just,
got it? See, this is not, this is in simplified form.
but let me tell you why I get it now.
Okay.
I look at the number 6 and it said 2 to the radical 24. So you already have 2 there.
Right.
So 2 is 4. But what's the next number could make me get 24?
6 times 4.
Yeah.
And
So
one of the 2's you got from
it's
square root of
already
4.
so I just choose B. You got it, got it.
Right? Yeah, I just want to make sure now how you got 7 and you didn't get 6. I want, because you're
Got it.
telling me 2 2's are 4, and there's your 4.
What this is, what that's why I stick in my head like I said, but what could be wrong? 2, 2, 4. But I'm not looking at there's a 2 beside the 24 already.
Already, that's right. You
Yeah,
already got a 2, and then you got a square root of 4. There's a 2. So 2 times 2 is 4.
you just kick in, just kick in.
Okay, that's why I went
what
back
what
to this.
yeah, thank you. What and what make 4?
Right. That's why I went back to this. How did you get that one right and you missed this one? Okay. Yeah, okay. Now you're all right, Mercedes?
Yes, I am. I am. I just
Clearer? Okay. That's
yeah, I just
wanted
got
to
it.
go back over.
I wasn't looking at the 24, at the 2 with the 24 at all. I was just keep looking at
Maureen, number 8. What's the answer?
it.
Maureen, number 8.
Maureen, wake up.
I was
Maureen, what's the answer? Tell me how you got it.
oh,
Rationalizing, getting rid of that radical in the denominator. So how did you get it? What's the answer? And tell me how you got it.
I didn't do that one.
You
I got
did.
that one wrong. I
Okay.
had, what's the answer? I think I had C was the answer.
Okay, Mercedes, you know how to do this one?
No, man, I didn't do it because I was guessing. I said, I want to leave it because
How did I say you make the denominator a rational number? That's what rationalization, getting rid of that that radical in the denominator. So this is, let me just put here, this is, let me write it here. This is 5 over the square root of 10. And we want to make that rational 10 just a number. That's why we call it rationalization. What was the rule I gave you? You remember, Maureen? What do you multiply by?
By 2.
No. Mercedes, you remember?
is it by Xmas?
No. You multiply by the radical. Multiply the numerator and the denominator by the radical. Okay. So let me just put times. So this will be times the square root of 10. There's the radical. Over square root of 10. So let's just put this here.
Square root of 10.
Multiply both numerator and denominator by the radical.
Oh,
Okay. So let me just underline this.
so the answer should be D, miss?
Answer is not D.
Uh-oh. What is B then?
Okay. All right. Now, when you
Okay.
multiply this, what do you get for the first one? What do you get for the numerator?
This, the one on the right
50.
one.
Who's telling me? Maureen, you telling me?
Oh, that's the best. It's so you want to. That's okay. Go ahead.
5 times the square root of 10 is what?
It's 2.
No, it's just 5 times the square root of 10. Square root of 10 does not have a perfect square, right? So you just repeat that. It just put 5 and then put square root of 10, right? That's what you have in the numerator. Let's just put that. 5 times the square root of 10 is 5 times the square root of 10. The 5 becomes a coefficient for the square root of 10. Okay, so that's what we have in the numerator. Okay, Mercedes, what do we have in the denominator? What did that tell you when you multiply the square root of radical times itself? What do you get? Square root of radical times the same radical square root. What do you get?
Number, miss? I'm not quite sure. You get about this 10? Get about the
Yeah,
same number?
you get 10, same number. That's right. Very good. Because that's what they said. When you multiply the square root by itself, you just get the radicand, just the 10. All right. Now, do you see that answer there?
Oh, just a minute. Yeah, go ahead now.
Do you see that answer?
That's D, miss?
No. Do you see the answer?
You keep going up and down.
Well,
miss.
okay. I have 5 times the square root of 10 over 10.
Yeah.
What is that equal to? One of those answers.
Oh,
Five
you can
over
see,
10.
miss? See?
No. Maureen, what did you say?
She said 5.
I have C too.
You have what?
I'm done to say.
A, B, C, and D.
Hey,
A, that's right, Mercedes, A. Because 5 and the 5 is 1 time, 5 and the 10, 2 times. So
Yeah,
you just have square root of 10 over 2.
I had that too, but I can't believe it. They changed it up.
Why
I
you
gotta stop
changing,
changing.
Maureen?
Yeah.
Because you're simplifying it, right? Because I
Yeah.
think I said to simplify. So 5 in the 5 is 1 time, 5 in the 10 is 2. So right here you have a 2. And what answer is that, Mercedes? Square root of 10 over 2 is A. Very good.
so you say right, what you say, miss? You say 5 into 5, 1. And 5 into 10, 2.
Yeah, because remember I said rationalize and simplify.
Okay.
So when you got to square root 5 over 10, you can factor out the 5. That just gives you a 1, right? And 5 times 2 is 10. So your answer is A. Got it?
5 times 2 make 10.
That's it. You really factoring out your
5
5.
and 5 into 10 is 2.
5
Yeah.
times 1 is 5. 5 times 2 is 10. What happened, Maureen? You said you had this and you changed?
Yeah.
You gotta stop doing that, Maureen. Just remember your rule now. When the goal is to make your denominator. We only rationalize in the denominators. We want to make the rational. We want to make this square root just a number, a rational. That's why we say rationalize, a rational number. Okay. And what do? You multiply both numerator and denominator by what that radical is. That's it.
Okay.
And the numerator sometime will not change. Sometime you may have to simplify it. In this case, we did. We just said 5 times square root of 10. but we did end up simplifying it because any radical times a radical of the same number just gives you the radicand. That's the number under the radical. So keep that rule in mind. So the square root of 100 times square root of 100 would just be 100, right?
Mhm.
Square root of 5 times square root of 5, just 5. So that's how we got the 10. But you have 5 and 10 both have a factor of 5. So 5 and the 5 one time, 5 and the 10 two times. Everybody okay? Well, let's say that you said the answer, so you're okay with that, right?
Yes.
Okay. Now we're looking at scientific notation.
Oh, it's this beat me up. I couldn't remember to get it.
Oh,
Give me
but
the
what is product? What does product mean, Mercedes?
multiply, miss,
Product. What does that mean?
to multiply.
Multiply. So when you multiply 6.73, let's just multiply the numbers first. Multiply 6.73 times 2.91.
Wait a minute. 6.73 times
Yeah.
2.
Yeah, you're taking this 6.73. Let's do it in steps. Let's put that there. Okay. Sorry. Let's 6.73. I just put 6.73. Multiply that times 2.91. Product you get from multiplication, right?
Yeah.
Okay. Now, what is that equal to? I'll say this. When you multiply that out, what do you get?
I got, let me make sure I write it down. Wait, it's 6. Oh, wait, miss, sorry. I missed a number. That is 6 points
6.73 times 2.91.
times 2.1 give
And
me
what do you get?
19.5843.
What do you get?
19.5843.
Okay. So we round that off to 19.6. Right? Okay.
Yes,
Now,
8. Yeah,
Okay,
8 added to 5 makes 6.
Maureen, did you get that? 19.6?
we had 6
And what do you do with the
7, 3,
powers? Times 10 to
6.73.
the what power? It's multiplication. So what do you do to the powers, Mercedes?
Two,
You
Fine.
add them.
You add them. So what's the powers? 4 and 3. So what's 4 plus 3?
Wait, we're
7.
7. I told you, I said 10 to the 7th power.
Okay, 10 to the 7. There we go. All right. Now,
1, 9,
now you don't see that answer there, right?
5,
Okay.
5.
Now, there's something you can do with the number that you're multiplying by the 10. That's by the 10 number and the power. If you reduce the number, you raise the power. Okay. If you increase the number, you lower the power. So if you make this, if you move this one place, you increase the power by 1. So what does this become, Maureen?
8.6.
I want to decrease this, move the
Yeah.
decimal.
1 space.
No, tell me what this becomes. I'm moving a decimal point one place between the 1 and the 9. So that's 1.96. But if I decrease it, I increase the power. So, Maureen, what's the power down on the 10?
Oh, I know.
And then
8. That's right. So let's just put the 8. And what answer is that?
See, miss?
C. That's it.
It's a tricky one, miss.
That's the operation that you should learn, that you can take your number. Remember your scientific notation. You have a number times 10 to a base. If you reduce that number by moving the decimal point one place, well, if you're moving to the left, that's decreasing, so you're going to increase the power. If you move to two places, you increase your power by 2. Right?
Okay.
So if I put it here between the 1 and 9, remember we want a number always less than 10. So that's why we're going from 19.6 to 1.96 times 10 to the 8. Answer C. So 2 steps, multiply the 2 numbers that's in front of the times the 10, and that gave us the 19.6. Follow your rules of exponents. Multiplying, you add the powers. So 4 plus 3 gives you 7. Now you're trying to get one of these answers. So this can be reduced by 1, move the decimal point between the 1 and 9, increase the power by 8. Okay.
Okay.
Questions on number 9?
This one is really, I don't know if it is the first I'm doing.
Okay.
Mercedes, you have a question?
Yeah, I'm saying, I think it's the first time doing this, something like this. So it's sound interesting. Man.
Yeah, I know, but this is a rule I want you to know. If you have a number in front of for the scientific notation, remember you have 2 parts. You have a number times the 10, and then you have a power. So if you decrease the number by 1, you increase the power by 1. If you increase the power by 1, you decrease the number. That's why you have, if I started with the 1.96 and I want to make this, say, a larger number, then I have to decrease the power. That's why the 8 would go to a 7 if I was going the other way. Mercedes, is that clear?
Yeah.
Yeah.
So when you look at these numbers, let me just, okay. Suppose, let me just give you a number. Suppose I had 32.8 times 10, and I'll say this to the 4th power. All right. And I want to write this as 3.28 times 10. What power would I have on there, Mercedes? What would be the power of the 10 now?
4 to 10 now would be 5.
That's it. Because I decrease, so I raise my power. Very good. You got it. Maureen, you got it?
Yeah.
Okay. All right. Now, let me just take another number. Go the other way. Okay. Suppose I had 9 .89 times 10. Okay, let me put here to the 6th power. All right. And I want to write this as 0.0989 times 10. What power would I have now, Maureen? What would be the power of my 10?
7.
Nope.
Or you decrease 5.
No. Mercedes, you know it?
I'm looking at it on sure.
Or be 10 to the power 8. 1, 2, 3, 4, 5.
What would it be, Maureen?
10 to the power 8.
8. That's right. Because I decreased by 2, so I raised my power by 2. Mercedes, you got it?
I'm trying to see how you make two space to the right to decrease.
Yes, remember I went 2 places to the left.
To increase.
No, I'm
Until-
decreasing.
Yeah,
0.0989 is smaller than 9.89.
yeah.
But I
Well-
moved it 2 places to the left to decrease it. So I have to raise my power by 2.
6.
6 plus 2.
So when you increase, you go back and put back your 2 and get 8.
Yeah, if I make my number in front of my 10 to the power smaller, I have to increase my power by the number of places I moved the decimal point. So I was here, so I move it here, that's 1. Put a 0, that's 2 places. So I have to increase this from 6 to 8, 6 plus 2.
Okay. Okay.
Got it?
Yes.
All right. All right, let's look. Did you do the word problems?
Go up and
No.
see me.
Maureen, you told me you were going to try those, right?
Yeah, I didn't get the time to do that.
Okay.
Let's go up. Let me see. Let's go up. Let me think. I think I did it today. Hold on.
Did you do the Mercedes? You do them?
I did some red problem. Let me see if it's it. I was wondering if I mix up the homeworks.
I will do it, but there is the time to play on it.
Okay, let's look at the word problems. Let's see, was that number? That's number 9. We are on number 10.
9.
Okay, number 10. Now, you have a table here.
Uh-huh.
United States, Canada, Mexico, and you have the population.
Uh-huh.
And you want to get a total.
Uh-huh.
That means you have to add these, right? So the US is 3.1 times 10 to the 8.
uh-huh.
So let's just put 8. Okay. All right. Now we want to add the Canada population. That's plus 3.38 times 10 to the 7.
Okay. 10 over 7.
10 to the 7th. That's
Plus.
7th power. And then we have
Right.
Mexico. It's 1.1 times 10 to the 8. So you just really want to add those. Can you add them the way they are, Maureen? Or do you have to do something?
I'm gonna set it up.
What do you
I
have
will
to
have
do?
to set up mine. I will have to set up mine to add it like that.
But can you add them just the way they are?
Yeah,
Why?
of course. That's what
No,
I'm saying.
you can't, because you have 10 to the 8th, 10 to the 7th, 10 to the 8th. You can
Oh, I
add the
see.
10 to the 8th, but we have to make this 10 to the 8th. What would that be, Mercedes, as 10 to the 8th? 3.38 times 10. That's why I went through that exercise before with you, because we know this one we've got to change. Now, this is, sorry, to the 7th,
That's in the
and we
7.
want to make it to the 8th. So, Mercedes, well, I want to make this something times 10 to the 8th. So let me put 10, and you tell me what that something is.
You have to increase my
Plus.
point.
What do I have to do? I'm increasing my power. So what, that's 3.38 will become what?
3 point. No, no.
What would it become? Mercedes? What would go here in front of that?
3.7. No, 3.8.
Tell me what to write here.
3.8
No,
times
increase the power, decrease the number. 3.38 becomes what, Mercedes? Decrease the number.
3 decrease.
0 what?
0.3 3.8.
That's it. Very good. Now you can add them. Now add them up. Tell me what you get. 3.1, 1.1, 0.38. What do those add to? You can just put,
3.1, right?
yeah, you can just put 3, because you know they all 10 to the 8. So 3.1 plus 0.338
0.
plus 1.1. What does that give you? This will all be times 10 to the 8. What's that equal to?
That's 6.538.
No,
I get 4.538.
that's right, 4.538.
That's
Mercedes, where are you making a mistake? So your answer would be
Oh, I see. I write one five.
4.538 times 10 to the 8,
10 to the
right? Because you
8,
made
yeah.
them
I know.
all to the 8th power.
I wrote
That's your
one.
answer.
I wrote one
You wrote
I
one
wrote one
incorrectly, right?
twice. I wrote one of them
Oh,
twice.
okay, right. So
You got to line them up with the thing.
yeah, you line them up, put 3.1 under it, put 0.338, and then put 1.1. Got it?
Okay.
Question? So that would be your answer. 4.538. Make that bigger. So this would be 4.538
Times 10 to the
times 10 to the 8th power. That's your answer. Questions?
Miss,
Yeah, funny.
I have to do some more of this to get the kicking of it.
Yeah, because that's why I went
And
through.
that's hard, what is to understand the movement of it and the difference.
Yeah. What I want you to know, you couldn't just add these as they are because they don't have the same power. You had to adjust one to make it the same power. Then it's just a straight add. Okay. Make sure
Okay.
you line up your decimal points if you're doing it without the calculator. But even with the calculator, make sure you put your decimal points in. Questions? So that's your answer. Add up all the populations, but before you do that, adjust the exponents so they all have the same power. So this involves an increase. That means the 3.38 is a decrease, right, Mercedes? A
Yes.
decrease of just one. So you just really move the decimal point one place. So it's 0.338. Got it?
Okay.
Okay, 11. Maureen, how did you solve 11?
Let me see.
That's another add, right?
Yeah.
So the warehouse starts out as 1.28 times 10 to the 5th. So we put that there. And then you add on 1.13 times 10 to the 3rd. Now there again, you see your powers are different. So you gotta make them the same, right? So let's just put that underneath here.
Let it be 1, 2, 5, 8.
Okay.
So, Miss, what you're saying is that when we see it like that, we got to make the powers the same to have to adjust the.
You have to make the powers the same in order to do the mathematical operation, whether it's addition or multiplication or subtraction or division. Your powers should all be the same. Now here they're not the same. So which one will you do adjust? I'll say these.
What's can you bring it down a little bit? Let me see what's the numbers in the reading.
Okay. Let me make,
It's 3.
okay. Okay, here we go.
Okay, so 1, 5, 1 of.
You add on for
Right.
offices, so you really want to add the original square feet of the warehouse to what you added on. But the powers are different. right? So Maureen, which one would you change?
I would change the power of 10 to the power 3.
And you make that what?
I would make it like 10 to the power 5.
That's right. Okay, so let's just take this and put it here. Okay, and you say you're gonna make the 1.13 times 10 to the 5th. So let me just put that here and you tell me what did you make it? Okay, so you made this 10 to the 5th, so let's just put a 5 here. So what was this changed to?
I would change it to 0,
Okay, 0,
0,
Point.
point,
okay, 0 point what?
113,
What goes behind the decimal?
a 0,
Okay, a 0, right? And what's next?
okay, 113,
Okay, 113. So how many places did you move it?
yes, so they move it
Zeros here. Okay,
3 places. No,
how many? You moved it 2 places,
2
right?
places, 2 places.
Okay, you moved it 2 places. It was
Yeah.
here, and then you moved it here. That's 2
Yeah.
places. Now you can add them. What did that become? What's that answer, Maureen?
What's the answer? Okay,
Add those 2 together. What do you get?
1,
yeah.
9,
1 and 0 is 1.
2. 0.291.
129, 1.2913.
Now 1.293
1.
times 10
Yeah.
to the
Okay.
5th
To the
power.
power 5.
That's right. Okay, so your answer is what?
See,
C. That's it. Answer C. You got it. Mercedes, you got that?
Yes, miss, I do.
Okay, very good. So those are cases where you may have to adjust your powers when you're trying to do calculations. Any
Okay.
questions? Okay, now,
I get
yes,
a clue here.
Maureen, question?
Right? I get a clue.
You understand now how you change the
Yeah,
number when you change the
Yes.
power, okay? Decrease the number, increase the power. Increase the number, decrease the power.
It's the power.
All right. Now I want to look at some probability. So let me do a new share. Right? And I want to look at probability. Now we said probability is how likely is something to happen, right? Now, what you should understand about probability is a ratio. So you can have a fraction, you can have a decimal, or you can have a percent,
Oh,
right?
uh-huh.
It's what you want to happen ratio to what could happen. All right. This is like they use it a lot in weather forecasting. What's the probability it's going to rain? Do you ever look at the weather and it says 50% chance of rain? All right. Okay. Or when the weather gets cold, so many percent chance of might be snow. Okay. So what you want to happen divided by the possible things that could happen. When you say 80%, 80% chance is rain. Okay, do you see these colored dyes here? See them?
Uh,
You see two blue ones, right?
Mm-hmm.
How many total do you see, Mercedes? How many of these eggs do you see?
Total of all the eggs you're saying?
Yes,
12.
12. So your probability that you just will pull a blue, and you only have two of them, is 2. That's what you want to get, right? Over the total possible. There are 12 eggs, so that's the possible. 2 over 12 or 1 over 6.
Okay.
All right. Now, if you wanted to pull, let's just call these orange. Maureen, what's the probability you get the orange?
There are 2 orange.
Okay, so what's the probability you get orange?
2 over 12.
2 over 12. All right. Now, let's just call all of these red, even though they're different shades here. So what's the probability you get a red one? Yeah, these, use these two. What's the probability?
That'd be 4 over 12.
That's right, 4 over 12 or 1 over 3. Okay, so you get it. We call that the simple, just one simple event. Like if you don't get the flu shot, the probability of 7 out of 10 chances you will get it. That's 70%. All right. Now, do you understand dye? Do you know what a dye looks like?
Yeah.
It has how many sides?
6 sides.
6 sides. And what's on each side?
Numbers.
Okay.
Number 1 to 6.
Yeah, number 1 through 6. Okay. So if you roll a die, like you throw the die and you get a 1, that's a simple event. But it's independent. It doesn't affect what you'll get on the second one. So we call them independent events. In other words, getting a 2 is not affected by whether you got a 2 before or whether you got a 3 or 4 or 5 or 6. Got it? So it's important that you understand independent events. Events that do not depend upon other events that may have occurred. It's like with a coin. Coin has 2 possibilities. What are they, Mercedes?
Head or tail?
Heads or tails. Can you get heads and tails together?
No, miss.
No, you either get
Must
heads or
pick
tails.
one or the other.
That's right. So what's the probability that you get a head on a coin? What would you say the probability?
If I flip it?
Yes. What's the probability? Give it to me in percent. What's the probability you'll get a head?
What should I say now?
As a percent, what would it be?
1%?
No. You have
then
2 possibilities.
you
You
get
have 1, you want to get a head. So that would be 1 over 2 or 50%,
oh yeah.
right?
Understand.
So you can say 1/2, 1 to 2, or you can say 50%.
Okay.
You
Either
got it?
because 1 is head and tail. Half is either head or the tail.
The 2 is the total possible things that can happen. A head or a tail. That's 2 possibles, right? But you can only get 1 at a time.
Yeah.
Can't
Yeah.
get them together. Okay.
Okay.
Now let's look at a spinner. You see the spinner there, right?
Yes.
Okay. How many slices do you see in this spinner? What's the total?
The total is 8 slices.
It's 8, right? Now, let's calculate the probability. So you know your total is 8, right? How many reds do you see, Mercedes?
4.
4. So what's the probability that you spin this spinner? And what's the probability you get a red?
The possibility to get ready is 3 to 4. 3 to 4. Am I calling
No.
it right
How
way?
many reds?
4.
What's the total?
Oh, the total is 8. It's 4 to 8.
That's right, 4 to 8, 4 over 8. And you can say 4 over 8 is 1 over 2, right? Or you could say 50%. We express all these different ways, okay? Got
Okay.
it?
Yes.
All right, Maureen. Aqua. What's the probability you get an aqua, Maureen?
3 over 8.
3 over 8, because you see 3 colors there. 3 over 8, so we put 3 over 8. And that. All right. Now, what about yellow, Mercedes? What's the probability you could get a yellow?
1 over 8.
1 over 8. All right, you got it. Okay, see, 1 over 8. Those we call just simple events. What you want to happen over the total things that are there. And the total is all these colors in the sweater. You count them 1, 2, 3, 4, 5, 6, 7, 8. All right. Now, can you get 2 colors at one time
Color plus 1. No.
when you spin it? No, you can only get 1 at a time. And if you land between them, you just spin it again, right? So we call these simple events when you spin this spinner and you get the colors, right?
Yes.
Now, if we spin the spinner twice, we call those compound events. All right. Now, what you get on your second spin is not dependent upon what you got on your first spin. So that's an independent event. That's another independent event. So you could spin it twice, but what you get on the second spin does not affect what you got on your first spin. Okay, so let's look at that same spinner. All right. Now, let's calculate what we would get. Well, let's see if you can see it. Maybe I have to put it here. There are 4 reds. Let me just put it here. Okay. I want you to give me the numbers, but it's kind of hard because you don't see this better. But I'll just put here. There are 4
reds.
reds.
Yeah.
Okay, let me make that bigger. And there are what? How many aquas? 3 aquas and a yellow.
1 yellow.
Right. Okay. So 4 reds, 3 aqua, and 1 yellow. Because to fill in this, I want you to put, okay. Now, what's the possibility? You have 3 friends who are spinning. They play a game here. Adriana, what's the probability she gets a yellow? Maureen?
1 over 8.
1 over 8. What's the probability she gets a red?
4 over 8.
4 over 8. So 4 over 8. Okay, Maureen. Bob gets an aqua and then a yellow. What's the probability he gets an aqua?
1 over 8.
Oh, no, Mercedes.
Yes.
Oh,
Yes.
sorry.
What's the probability that Bob spins and gets an aqua on his first spin?
Add 3 to 8.
That's right, 3 over 8. What's the probability he gets a yellow on the second spin?
1 over 8.
1 over 8. Okay. Okay. Now, Charlene spins. She gets a red and then an aqua. So, Maureen, what's the probability she gets a red?
3 over 8.
A red?
Oh, 4.
4 over 8, right?
Yeah.
That's 4 red, right? What's the probability she gets an aqua?
3 over 8.
Yeah, over 8. Okay, 3 over 8. Okay, now I put the fractions here. 1/8, 3/8, 4/8. Because typically when you're given something like this, you're given a multiple choice. So you pick
Yeah.
out the fractions. So I put the possible fractions and you see we have them. 1/8, 3/8, 4/8. Now, when you have an and event, that is you have two spins, you use what we call the multiplication rule. So the probability of getting a yellow and then a red would be probability of yellow times probability of red. So that's why we did these first. All right.
Mhm.
That we call that the multiplication rule. So let me just put here. We say probability, and I would say the let's see, yellow, probability of yellow and red on the spinner. And that's multiplication. That would be the probability of the yellow times the probability of the red. So the probability of the yellow was 1/8, and for the red was 4/8. So that would be probability. I'll just write it out here. Probability of yellow times probability of red. So we've already figured those numbers. So what was the yellow, Mercedes?
1/8.
Okay, 1/8. Okay, now I'll put this in. Okay, so I can use it times. And what was the red?
The red was 4/8.
4/8. Now what is that equal to, Mercedes? You multiply that out. What do you get?
I would get 4/8.
8 times 8?
I didn't do the bottom.
Well,
just-
that's what probability is.
Oh lordy! After the top and bottom.
Well, doesn't it say 1/8 times 4/8?
Yes.
Yeah.
The slash works just like the dash.
Oh, I see.
Okay, so what's the answer, Mercedes?
64. 4/64.
Yeah, 4/64. All right.
So that
And
would
you
be
could simplify this. This simplifies to what?
thinking.
4/64 simplifies to what?
Oh, just a minute. Let me see. 64.
4/64 simplifies to what?
What is this thing doing? Sorry, Miss Barbara, 1 second. 4/64.
Yeah. What does that simplify to?
16.
What?
I got 16.
4/64? It's still a fraction, not a whole number.
Oh, 4 into 4, 1.
Yeah, 1.
That's 1/6.
1 what?
1/16.
Yeah, 1/16. Okay. Okay, so that's whenever you use it, when you have two events occurring, you use there are and you multiply. But first you find the probability of each event and then you multiply them. Got it?
Okay.
Now, if you were drawing something, say, out of a basket, and you don't replace, that's called a dependent event, right? Let's see if I have one I can show you here and tell you the difference. And usually, you know, dependent from independent. Okay, now here's a case where we have 8 students here and the slips are in a bag. And we want the probability that someone pulling out a slip of paper will get one name than the other name, right? So the probability that you pull out Brandon names 1/8. Probability of Monica is 1/8. So Brandon and Monica would be 1/8 times 1/8, 1/64, like we did with the spinner, right?
Yeah.
But now if you had dependent events, now I've got an example for you here. You have a bag and it has tiles, 6 red, 4 green, 3 yellow, 2 blue.
Yeah.
Now, you're taking a tile out, but you're not putting it back. So if you take something out and you don't replace it, you've got a dependent event. Because what happens when you take something out and you don't put it back, then your total changes, correct?
Yes.
Like if you had this total, you have 10, 13, 15. So if you take a blue and you don't put it back, how many do you have left, Maureen?
If I don't put it back, I got 2, 4, 6, 13.
If you take a blue out and you don't put it,
14.
that's right, you have 14. If you take a red out, you'll have what?
13.
Yeah, because every time you take one out, you don't put it back, you're decreasing your total by 1. So those are dependent events. So you look at the clue that says no replacement. If it says it didn't replace it, then that means it's a dependent event. And your totals change. That means if your totals change, your probability is then calculated. All right. So if you took a yellow out and you left with 14, then your probability is different than if you say I took a yellow and a green out, because now you got 2 out, right? And that leaves you then with 13. Okay. Now, so I put down here the totals. Red, green, yellow, 2, blue. All right. Now, the simple probabilities, and you can just tell me what they are. They're a total of 15, and I gave you the number. So what's the probability that Ramona takes a yellow out, Mercedes?
1 to 8, if she took the yellow out.
No. It's 15 tiles.
Oh, sorry.
We're
You said-
talking tiles here now. There's 15 tiles in the bag.
No,
So
that's
what's
the-
the probability she takes a yellow out?
that would be 1 to 14.
No,
How many totals
this
again?
is a simple event. And you're taking just one color towel out. What's the probability Ramona is taking these towels out of the bag, right? So what's the probability she takes a yellow towel out?
If you take one yellow towel out, probability of 1 to 14.
No, Mercedes, Maureen, you know what it is?
1 to 15.
How many?
1 from 15. Like you said, it's
No.
15.
How many yellow are there?
3.
So 3.
Yeah.
It's
That's
1 to
it.
15.
We're doing
Yeah.
this, that's the simple event.
Oh, the
Just
other
like
way
we did before, right?
Oh,
Oh, the other way around. I got it.
Okay, so 3 out of 15. What about the green, Mercedes?
How much green towel? Oh, yes, it. Okay, it
Yeah.
was 4. So if I take a 1 from the green,
What's the probability? This is a simple event that she's taken out one towel. What's the probability she pulls the green out?
it's a probability of 3 to 15.
How many greens are there?
4.
So why are you saying 3?
If I take out 1 of the green.
4
That's
out of 15. This is just a simple event. Now, if she takes a blue out, what's the probability? Mercedes.
2 to 15 then.
Yes, 2 out of 15, right? And if she takes a red, what is it?
It would be 6 out of 15.
That's right. We're talking just a simple event now, right? 6
Oh.
out of 15. Okay. That's just a simple event. You've got this number of red, this number of green, this number of yellow. this number blue. So a simple event is just a number of the colors you had over the total, right?
Mhm.
Now, and they are right here. They are the fractions. I put them here. Okay. So if she draws 2 tiles at the same time, then these are compound events. So once you take 2 out, you no longer have 15, you have 13, right?
Yes.
Got it? So if you take the first one out, you have 14, and the second one out.
A question right in there, Miss Barbara. Can
What's
you
the-
scroll back? A question right there. Yeah, stay right to the bag with the color for me. I want to get it straight in my head.
Okay.
Can you go back with the bag with the color? Yes.
Okay, there we go.
So probability now is 14, it's 14, sorry, it's 15 in all. So
Yeah,
if
that's the total possible outcomes, 15.
yes, so you're saying although if blue is 2, if she took out blue, then you say it's 2 to 50.
No, I'm saying what's her probability? What's the chances of her getting a blue tile when she just selects 1 tile? 2 out of 15, because there's 2 blues and there are 15 total.
That's the question I'm asking you, Miss.
What's the question?
Question. Well, you just say it the other way around. That means you take out blue, you should take out 2. So it's
No.
2 to
I didn't say 2. I say she selects a tile, 1 tile. Ramona pulls a tile out of the bag. What's the probability of her getting a blue tile? The number of blues, because that's the possible, over the total, which is 15. I'm talking just a simple event of pulling something out of the bag. Now, Sadie, did I answer your question?
I'm not sure because remember, I'm looking at when you said to take out one blue.
No,
I'm
I didn't
looking
say,
at-
no, Sadie, I didn't say that. See, that's where you're going wrong. I don't know what she's taking out. She's just pulling a tile out. The probability, remember, she's not looking in the bag and pulling a blue. She's
Okay.
just pulling a tile out.
I will out.
You
Okay.
got it? So the probability of her getting a blue would be 2, because there are 2 blues, over the total, which is 15.
So when you say what's the possibility of getting a blue, you gotta say 2 over 15.
What's the
Okay.
probability? The
'Cause it's only-
probability of getting a blue is the number of blues over the
Okay.
total.
Yeah, okay, got you.
Probability of getting a green is the number of green tiles over the total.
Over 15. Okay, great.
Got it?
Yes.
Probability of getting a yellow is 3 over 15, and red 6 over 15. Got it?
Yes, ma'am. Thank you.
Okay. Now I want to look at dependent events. Now, once you don't put it back, then your total changes, and that's a dependent event. Okay. You still got 15 tiles and you're not replacing it. So the first event is just a simple event. So what's the probability of her getting a red, Maureen?
Possibly again away.
Mhm.
6 out of 15.
6 over 15. Okay, because that's right. 6 over 15. Now, remember, she does not put it back. All right. Now, what's the probability of her getting a green as her second tile?
4 over 15.
Nope. 4 over 14. Because remember, I said she didn't put it back.
Yeah. Or you said, oh, put it back. Oh,
Okay. You heard me say you don't put it back. So now you reduce your total. You got it?
Miss,
Yes.
why would it be 14? 6 from 15 is less than.
Wait, just a minute. Wait a minute. I'll say these. If you have 15 tiles and you pull 1 tile out and you don't put it back, how many are left?
14 left.
14. That's why you have 14.
Now I'm going back to the color. I'm thinking of the color. When you say pull out 6, I'm thinking the 6 red ones.
A red. What does
Oh.
A mean?
1, 1.
A red and A green.
I see, yeah.
Got it?
Yeah.
She's pulling a towel. She doesn't know what she's pulling. She's not looking at the colors. She pulls a towel and she pulls a second towel. So the probability of her getting a red and then a green for the red is 6/15. And for that second towel, it's the green, that's 4. But now her total went down by 1 because she's taken 1 out. You got it?
Okay.
Okay. Now, suppose this is a second drawing, right? She takes a red and a yellow. So Mercedes, what's the probability of the first event of her getting a red?
If she took her red towel out,
Yes,
possibility of 6/15.
that's right, 6/15. All right. Now, what's the probability of her getting a yellow as a second towel?
How much? 4/15, is it? 4 yellow.
What is
towels?
yellow?
4/15.
No, how many yellow?
I don't remember. That's why I'm
Right
saying it.
here, I've got them right here.
Right there,
Yeah,
Right
three,
here, I put them here for you.
3. I saw it. I was
Yeah,
looking
that's
at
why I put them there because you can't see the bag. Okay, so that would be 3 over what?
15
But you just took 1 out.
or 14.
That's it. You got to remember now, you're not replacing, so your total is going down by 1 every time you take 1 out. All right,
Okay.
got it?
Yes, ma'am.
Okay, okay, let's just finish this. Now, Maureen, probability of getting a yellow on the first try,
3/15.
3/15, right? What's the probability she gets a blue? Remember, she's not replacing it. So what about the blue?
2/14.
That's it, 2/14. You got it. Okay. Now, Mercedes, we're going to, I think this may be the last one. Okay. So what's the probability of her getting a green, Mercedes?
Agreeing that will be
I've got them
That-
right here.
3. Agreeing, you say? Or 4
Yes.
over
4/15. So let's just put that here. 4/15. Now, what about a blue, Mercedes?
2/14.
That's it. You got it. Very good. So now we've got all our probabilities for our towels, right? And you see all your fractions here. I put them down here. They match what we selected, right?
Yeah.
Yes.
Okay. Now, when you getting these probabilities, when it says, what is the probability? Say if you say, what are the probabilities of a red followed by a green? You multiply these probabilities. You got it?
Oh,
So the way you would write this, okay. Let me just write this. So what is the probability of, and I'll take one that we had, something we had here. And I'll say a green followed by a blue. What's the probability of green and blue? That's a multiplication, all right? So you multiply the probability of green times the probability of the blue. You got it?
okay.
So that's why we did the simple probabilities first. So you take the probability of the green. What was the probability of the green? You remember? Let's scroll back up. Probability of green was 4/15, and the blue was 2/14. So you put 2, 4, what was that? 4/15
And 2.
times 2/14. And you multiply those out. Got it?
Oh,
Questions?
you're gonna, oh, you multiply, you're gonna say 4 2
4
14,
times 2 is 8, and then 15 times 14.
Oh,
Got it?
Yes.
I'm doing the slash because it's easier. But it'll be, these are the numerators, 4 times 2, denominators 15 times 14. Questions? Did you understand this? Was this clear?
yeah.
Yes, I'm getting it,
Okay,
mister.
well, I'll be sending you this session because remember your next homework, we'll have some simple probabilities. Okay.
Miss.
All right, we're gonna stop here. Remember,
Yeah.
we don't meet on Monday. That's a
Yeah.
holiday.
Uh-huh.
And I sent you, Mercedes, I hope you get the homework. I sent it to you.
I hope I get it today.
Yeah.
I said when I came in, it wasn't in the mail.